They look at each other.
Okay, so today we are going to. Today, we're going to finish. Actually, you did finish 4.3, so we're going to kind of review 4.3 a little bit, and then we're going to get into 4.4, 4.5, which is accounting. We're ahead of the 2 o'clock class, so we'll get through the rest of this. That should not be a problem. Due today, you have Connect Math Homework 4142, and you will notice on there, if you have not already, those ones that we did in class, the quiz in last class, right? The problems are in there. Sunday, you have Connect Math 4.3 due, and we're going to go over some of the quizzes from today. Will be on that homework. Next Tuesday, you have your last homework due 4.4 due before the exam on Thursday. Your exam 1 is on Thursday. There's no class on Tuesday, but I will be here, and the tutor will be here for an optional review session. Also, on Monday, if you guys want to come early at 4 o'clock, Andrea will be in there, and she'll be doing some review with you guys if anybody wants to come. Is anybody interested in coming early on? So yeah, so hop on in there and just come on in here, and then you can grab her and go in there and start working on some review stuff in there before class. So next Monday, 4 o'clock. Okay, exam 1 is in class Thursday, October 7th. It covers chapters 1, 2, and 4. See the study guide. Study guide is your best way of kind of sorting out what's on that. Everything's in there pretty much. Bring a pencil. You also can have 1/2 page, one-sided of notes. So a half of a 8.5 by 11 page, one-sided, handwritten notes, anything you want on there. I don't care. The idea is that the process of making that half-page notes will force you to organize the material that helps you learn it better. You also need a basic calculator. Who does not have a basic calculator? Okay, because I can bring some. I'll bring some with me, so you guys can use those. Scratch paper if you need it. Most people don't, but if you like to have a lot of room to kind of write other stuff on, then you could feel free to bring that. And then your binder in order. And again, I have some extra binders over here. They have, like, my sister's a law firm written on them, but still they're binders. They're free. I think there's like one that doesn't have anything written on it. So feel free to take one if you like. And then it should have divided into 2 sections. The first section should be your quizzes in order, completed and corrected, right? Your other section, you should divide it. And some people are using their syllabus or colored syllabus as a divider. That's a good option. The other section should have all your notes, again, complete and in order. And you can get extra credit for that. No cell phones or any other communication devices, so no ear things or no smartwatches, any of that stuff. Okay. There's tutoring drop-in. Andrea is available Wednesdays from 2 to 5. Sorry, 1 to 5. I did that again. 1 to 5. And Veronica is available at some point. You can have your smartwatches on now, guys. It's fine. Be quiet. Download your Penji. So the best way to get into the drop-in tutoring is actually to hop into Penji. So I would do it like this. I would just go to LTC, tutor, maybe just type in tutor, how to sign for free tutoring. Something to do, so it's taking for forever. Okay, so maybe I'll do that one for too long. All my tutoring. There we go. Click on that one. Is our website just down or something?
It wasn't working well this morning either.
Okay, well, we'll show you later then, apparently, because mine is not working. So momentarily, we're going to be, okay. How does that for tutoring? Just click on this Benji scheduling app right there. Or do I do the sign up? These are online. Drop-in scheduled, online, drop-in. Let's try that one, number 2. Oh, whoa. Okay, well, that's weird.
That's a tutorial. Just click the
Oh,
app
sorry,
button.
the first one. Okay, the first one. I got it. Thank you. And then get started, or if you've already used it, you can do the sign in. And then put your school's email address. You click on that, it'll make you validate it. Once you've done that, then it's going to get easier and just click on the sign in. And then it gives you, obviously we didn't do that, so we should have prepped that. So you put in your school email, it will ask you for, I think, your class web or your Zone mail. You shouldn't ask anyways. I think it asks you for any email. Oh, it'll ask you to set up a password. So put in your school email, your Zone mail email. It'll ask you to create a password. And then it will send a verification link to your Zone mail email address. And then once you do that, it'll let you get in there, and you can hop in. And we'll have to show you later because obviously I did that as well. Right. So then once you do that, once you confirm your email address, add Math40 as one of your classes. And then once you add Math40 as one of your classes, then you can click on Math40 and hit next, and it'll show you the available tutors.
Tuesday, 2 to 6.
Oh, sorry. Okay, good. So I flipped you guys. She's 2 to 6 and you're 1 to 5.
Yeah.
Okay, my bad. Okay, great. Thank you. You can also email any of them, Andrea, Veronica, or Victoria, and set up an hour. So go over stuff with them. Or if you want to get a buddy, then the 3 of you can all get in together and work on stuff. Okay. All right. So let's take a look. The very last thing we did last class. Remember complementary events. The complement of an event E is E complement. If you add up their probabilities, so E complement is everything that's not E, right? So it's an either or. Either you ride a bike or you don't. It is either heads or it wasn't, and you flip the coin. Either you roll a 4 or you didn't. When you add up the probabilities, they're darn well better equal 1 or 100%. Because it's everything's either going to be in one group or the other group. So we made use of this because of that super, super common one, the complement rule. Very, very, very often, we want to know the probability of getting at least 1. Right? I need to have at least 1 part in order to make my flush. That's what I always think of, but there's other situations. So how do we find that? It's really hard to find at least 1, because you got to find probably 1, 2, and 3, and it's not as clean as you think it is, because there's different ways of getting 2 or 3. So instead, we find the probability of none and subtract that from 1. It's just a lot easier, faster, quicker. So if you guys remember, my problem I had was the probability of getting at least 1 4. Well, these are all the ways of getting at least 1 4. Rather than computing all of those, I'm just going to compute the probability of getting no 4s and subtract that from 1. How do I not get a 4? Well, the beauty of it, this is only one way of getting none. No, no, no. So probability of no times the probability of no times the probability of no. Right? So 5, 6 times 5, 6 times 5, 6. Find that number, subtract it from 1, and you're good to go. So you guys had this problem before you left. Right? And the idea was, Yep, so this is on your notes. I think it was on the bottom of page 9. Oh wait, top of page, I don't know, what is that? Well, 10, top of page 10. And the idea was, what's the probability that at least one, here's 4 people, what's the probability that at least one of them buys a bow tie? So the probability that at least one buys a bow tie, so I'm going to put probability of at least one, that at least one is a bow tie. It's not easy to find 1 minus probability that, and then whatever this is, at least one, instead of that, write the word none. None, and then write the rest of whatever this is. None is a bow tie. Right? So if I want to find the probability that at least one person bought a bow tie, I need to find the probability that none of them bought a bow tie, because that's a lot easier to compute. Right? It's just no, 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 no. Right? Super, super easy. So if there is a 3% chance that he bought a bow tie, what's probably he did not buy a bow tie? 97%. Right? 3% chance he did, 97% chance he didn't. What's the probability that she did not buy a bow tie? Guys, with me, exam in a week. Come on. 97%. What's probably he did not buy a bow tie? 97%. What's probably she did not buy a bow tie? 97%. So each of them has a 97% probability of not buying a bow tie. Do I want one of them, like him or her, to have bought a bow tie, not buy a bow tie, or do I want all of them to have not bought a bow tie?
One of them.
I need none of them to have bought a bow tie. Why? Because the problem is, if I want at least one, I need to find the probability that yes, that he did and she didn't, plus the probability that he didn't, and she did, and he didn't and she didn't, plus probably that he, yes, like no, no, yes, no, and I need to find the probability of no, 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 yes, and that's just for one person buying a bow tie. Then I gotta find the probability that 2 of them buy a bow tie. So it could be yes, yes, no, no, yes, no, yes, no, no, yes, yes, no. I mean, there's all these different ways. I gotta find them all and compute them. That's too many to compute. It's a lot easier just to find this one, just this one path. So understand what I'm saying? Either find all of these other paths and add them up, or just find this one path and subtract 1, because the purple group is 1 minus the red group. 1 minus the red probability. Does everyone understand why? All the probabilities have to add up to 1 or 100%. If I want at least one is any one of those. And it could be 1, it could be 2, it could be 3 in any order. It's hard to find that. Instead, find the probability that none of them have and subtract it from 1 to get the rest of it. So we need to find the probability that none of them have bought a bow tie. No bow ties. So the probability that he did not buy a bow tie, and she didn't, and he didn't, and she didn't. And so we what?
Multiply.
Good. Try it again. And so we what?
Multiply.
Multiply. So I need him and her, and him and her to all not have bought a bow tie. Right? No bow ties at all. None. So, and multiply. And then subtract that from 1. So this is going to be 1 minus, this is 0.885. Yeah, I think. So it ends up being 0.115. Good. I need thumbs. Totally got this, and kind of got this. No idea. Where are you guys at? Okay. Talk to your neighbors. 30 seconds. Talk to your neighbors. All right, so let's bring it in, guys. All right, everybody, we can sort it out a little bit more later. We're going to move on. So addition rules of probability. Well, you guys can talk about it later. It's okay. Addition rules of probability. Two events are mutually exclusive events or disjoint if they cannot occur simultaneously. If it's impossible for them to occur simultaneously. For example, a puppy cannot be a chocolate lab and a yellow lab at the same time. Right? You cannot have brown eyes and blue eyes at the same time. If they are mutually exclusive, then addition rules, or probability of A or B, you just add their probabilities. If they're not mutually exclusive, that means they have some overlap. It means you can be both at the same time. So that means you need to, for A or B, you add the probabilities and you subtract the overlap, right? The probability that they're both. Remember, ORs mean you add the probabilities and subtract the overlap if there is any. So ORs you add. Try that again. Ready, everybody? 1, 2, 3. ORs you add. Okay, it's important you remember that for the exam because it's counterintuitive. Okay. Multiplication, prod A and B. If they're independent, you just multiply their probabilities. If they're dependent, then to find the probability of A and B, you find the probability of A, which means that A has happened. You multiply that by the probability of B, given that A has happened, right? Because A has already happened. So that's the kind of thing you have to pay attention to. You can't just multiply the probabilities if they're dependent. You have to find the probability of B given that A has happened. Again, though, probability of A and B, you're going to multiply the probabilities, right? So again, and we what? Multiply. Try it again stronger. Ready? And we what? Multiply. Good. So that leads us to your first problem. Section number 1, my bad. Which is this one. So the first one is all were on time. So does that mean that the first one or the second one was on time? Or does that mean the first one and the second one were on time? And. Ands are going to what? All right, so keep that in mind. B, none were on time. Does that mean that just the first one was on time, was late? Or the second one was late? Or the first one and the second one were both late?
First and second both late.
Both late. So that's again going to be an and we multiply. And then we got this at least 1. So remember, what you want to do is do 1 minus, replace this with none, right? So at least 1, replace that with none. None was on time. If none were on time, that means that what? They were all late. They were all late. Does that make sense?
Yeah.
So that's what you need to find, so then and subtract from 1. All right, so I'm going to give you guys...
So C is B?
No. C and B are complements of each other. Because either you have at least 1 sibling, or you have none, no siblings. So having at least 1 sibling and having no siblings is not the same thing. They're complements. Does that make sense? So your complements, it means you can subtract one of them from 1 to get the other one. All right, I'm going to give you guys 2 minutes to find these. Ready? Go. Okay, so first off, what's the probability that a plane was on time?
Something.
71.6%. How do you write it as a decimal?
0.76.
Okay, so what's probably the first claim was on time? What's probably the second claim was on time? What's probably the third claim was on time? So, I'm trying to find the probability that the first one and the second one and the third one were on time?
Yes.
Yes, so and we do what?
Multiply.
Multiply. What did you guys get? Three decimals.
0.367.
367? Okay, good. Now, then you're going to find the probability that none were on time. That means that the probability that the first one was late and the second one was late and the third one was late. That's what that means.
It means that we must do.
If none were on time, they were all late. Late and late and late. So, you got to figure out what's probably that the first plane was on time.
0.716.
Yep, 0.716. What's probably that first plane was late?
0.284.
0.284. You have to, right, those are complements. Either it was late or it was on time. If there is a 71.6% chance that it was on time, that means there's a 28.4% chance that it was late. Does that make sense?
Yeah.
Then you find probably that the first one was late, and the second was late, and the third one was late. So find that. And then remember, probably at least one was on time is one minus probably that none were on time. Okay, a couple more minutes. Okay, let's go over this. So, probably that none were on time means probably the first one was late, and the second was late, and the third one was late. What's probably the first one was late? Yep, subtract 1.284. What's probably the second one was late? And the third one? And we what? Multiply those and you get 0.023. Probably at least one was on time. That's one minus probably that none were. You already found none. Right? Plug that in there. 1 minus 0.023. 0.09. Oh wait, so sorry, my bad. 977. Does that seem right? Okay. Good. I'll give you guys a second. Alright, I'll give you guys 10 seconds to take a look at this. Take a picture if you need it. I'm moving on. Moving on in 5, 4, 3, 2, 1.
We have to add
Okay. Now, I flip a coin and I roll a dice. What's the probability that I roll a dice and I get a 4? What's the probability I get a 4? 1 out of 6. Now I flip a coin. Oh, I flipped the heads. Now that I flipped the heads, now it's a probability I roll a 4. Still 1 out of 6. They don't change because they're independent of each other. So it's probably a 4 given nothing, the same as probably a 4 given I flipped the tails. If they're the same, they're independent. Right? And again, you're comparing the same thing. Probably a 4 with probably a 4. The only thing is this is given nothing, and this is given that you flip the tails. Right? So that's how you figure out two things are independent. Probabilities stay the same, given something. So here, 2 questions. First one is, are yellow and male mutually exclusive? Why or why not? So 30 seconds with your neighbors, figure that one out.
They can occur simultaneously.
Okay, what do you guys think? Are yellow and male mutually exclusive? No. No, why? Yeah,
one younger than you, sisters, one
At the same time.
older than you. Oh, really?
Make sense? Everything good? Okay. Here's another question. Are yellow and male independent? Why or why not? You guys want a minute for this one? Okay, take a minute for this one. All right, let's take a look. So, how would I find out? Well, yellow and male. So again, remember this only applies to this sample, not any sample. I'm not talking about Labrador puppies in the whole world. I'm talking about this sample and this one rescue. So what has to do with yellow and male? Which numbers? 4, yeah, 4 yellow males. What else? 12 total males. What else? 6 the total yellows, and then what? 20 the grand total. Notice it makes a rectangle. It will always make a rectangle, right? Because you have what you're interested in. It's row total, it's column total, and the grand total. Then you're going to make ratios. Do you guys want to go side to side, or do you guys want to go up and down?
Side to side.
Side to side? Okay, that's fine. So I'm going to look and see if is 4 over 12 equal to 6 over 20. I could also go down. I could look at it this way and ask, is 4 over 6 equal to 12 over 20? They will always either both be yes or both be no. That's how ratios are set up. So are they equal?
No.
No. So it means that they are dependent. So what your answer will be on the exam is you will say, are they yellow independent? You'll say no, they're dependent. When I say why or why not, you'll say because 4 over 6 is not equal to 12 over 20. Or you could have said 4 over 12 is not equal to 6 over 20, either one, right? Does that make sense? But remember, you got to use those numbers because we need to compare male to male, like male given yellow to male given nothing, or yellow given male to yellow given nothing. You're not comparing probability of male and probability of yellow. Those should never be the same. Like should the probability of rolling a 4 be the same as the probability of flipping a coin? No. Right? They're independent. But those things don't need to be equal. It's the probability of rolling a 4 compared to the probability of rolling a 4 given I flipped a coin and got tails. Right? Both times you need to be comparing the probability of rolling a 4 to the probability of rolling a 4. Just one time it's given nothing, and one time it's given what you flipped as a coin. All right. This is slightly out of order, sorry. And this was supposed to be before, the other one. My bad. Right, so this goes back to that multiplying. Why does and mean multiplying? So think of it as when you're drawing these trees as it's a river flowing. And the river branches. A third goes to red, 2/3 goes to blue. So I go towards red, and then it branches again. A third goes to red, 2/3 goes to blue. But it's not a third of the whole river, it's a third of a river, because I've already branched, right? So you can kind of see here, it branches, so only a third goes to the first red, and of that, only a third goes on. It's a third of a third. Of means multiply, so a third times a third, 1/9 goes to the final red. So that's what I say about the trees. If you can write it as a tree, anytime you have an and problem, and you're really, really stuck, like even with this last one, if you wanted to, you could make a tree. You write in your probabilities and then sort out where you need to go to get there. Anytime you have an and those kind of, an and is a story, right? The puppy was yellow. So first you go down the path towards yellow. and the puppy was male. So then you go from there, you go the path towards male. Right? So think of these, anytime you have an and, it's basically a story. This happened, and then that happened, and then this happened. Okay, so speaking of trees, an urn, there's 3 urns. So what's the first thing you're going to do? You're going to pick an urn at random. So you've got 3 choices here. Urn 1, urn 2, urn 3. I need you guys to do a couple things. First, find the probabilities on each of these branches. And then second, if I went to urn 1, then what's going to happen? I'm going to draw a ball. What are the possibilities for my ball? I could draw what? Red or black. If I went to urn 1, figure out what the probability is that I drew a red ball, and the probability I drew a black ball. If I'm on urn 1, how many red balls are there? 4. How many black balls are there? 1. So it's probably I draw a red one?
4.
4 out of the total. There's 5 of them. 4 out of 5. Right? So you guys should find the probabilities. Find these probabilities here. Find that probability there, and then find the rest of how the rest of this stuff goes. So I'll give you guys 2 minutes for that.